Hi everyone. Today we're going to study permutations. Let us define permutation. Permutation is an arrangement of items where order is taken into consideration. There are ways to find permutations. Number 1, the counting principle. Number 2, permutation formulas. Let us study the counting principle, or sometimes called multiplication principle. The counting principle states that the total number of outcomes for an event is found by multiplying the number of choices for each stage of the event. Let's have an example. How many 3-digit numbers can be formed from the numbers 3, 5, 7, and 9 if, letter A, repetition of digit is allowed. Letter B, repetition of digit is not allowed. Let us solve for problem A. For the permutation, let us write 3 blanks here to represent the 3-digit numbers. Each blank here represents the number of choices for each stage. So for the first blank, there will be 4 choices of the digits. So in here we can write 4. For the second blank, since repetition of digit is allowed, there will be 4 choices again. For the third blank, and repetition is allowed, there will be 4 choices also. And then, let us multiply these numbers, 4 times 4 times 4. And the answer is 64. There are 64 3-digit numbers. Now for letter B. This time, repetition of digit is not allowed. So again, we have 3 blanks here that represents each stage. And we're going to put the choices for each stage. For the first blank, there will be 4 choices because there are 4 digits here. Now, suppose one number is already chosen here. The next blank, there will be 3 choices only. And now, there are 2 numbers seated on our blanks. So it means to say, since there is no repetition allowed, the third blank has 2 choices only. So let us now multiply the numbers 4 times 3 times 2, and that is 24. It means there are 24 3-digit numbers and repetition is not allowed. Let's go now to permutation formulas. And this is letter A. The number of permutation of n number of items taken R at a time is given by this formula. P of n of R. Take note that the symbol here, this is n factorial. So the formula is n factorial over the quantity n minus R factorial. And this n factorial is simplified into n times the quantity n minus 1 times the quantity n minus 2 up to it reach 3 times 2 times 1, and 1 is the last number. For example, if we have 4 factorial, this is equal to 4 times 3 times 2 times 1, and the final product is 24. By definition, take note that 0 factorial equals 1. Let us have example 1. How many 3-digit numbers can be formed from the numbers 3, 5, 7, and 9 if repetition is not allowed? Remember, this problem was solved in our previous topic on multiplication principle. Using this formula, let us now write P of 4 because there are 4 digits, namely 3, 5, 7, and 9, comma, and this is 3 because the required is 3-digit number. This is equal to n factorial now becomes 4 factorial over the n minus r is now 4 minus 3 factorial. Then let us simplify this 4 minus 3. We have 1 factorial. Simplifying further, the 4 factorial becomes 4 times 3 times 2 times 1 all over 1 factorial is also 1. And our final answer here is 24, which is the same answer in our previous example. Let's have example 2. How many 5-letter words, so this is with or without meaning, can be formed from the word liberty without repetitions? So our formula is P of 7, 5. The number 7 comes from the number of letters in the word liberty. And this 5 is the 5-letter word that is required in the problem. This is equal to the n factorial is 7 factorial over the n minus r is now 7 minus 5 factorial. And this 7 minus 5 is 2, and we will take the factorial, and this is now equal to the 7 times 6 times 5 times 4 times 3 times 2 times 1, that is for the 7 factorial, all over the 2 factorial is 2 times 1. We can cancel this 2 times 1, and there is 2 times 1 also in the denominator. So let us multiply 7 times 6 times 5 times 4 times 3, and the product is 2,520. These are the 5-letter words that we can form from the word liberty. This is our final answer. Let's have letter B formula of permutation, and it says the number of permutation of n number of items taken all at a time. So this is P of n equals n factorial. For example, how many ways can you arrange 5 different books on a shelf? So this is equal to P of 5, and that is equal to 5 factorial. And we know the 5 factorial is 5 times 4 times 3 times 2 times 1. And the product is 120. So we have 120 ways to arrange 5 different books on a shelf. This is our final answer. Example 2. How many 4-digit numbers can we make using the digits 3, 6, 7, and 8 without repetitions? So we write P of 4, there are 4 digits here, and 4, because we require a 4-digit numbers. Simply means we are taking all the digits at a time. So this is equal to 4 factorial. So 4 times 3 times 2 times 1 equals 24. This is our final answer. Letter C. If there are n elements in a set and r sub 1 are alike, r sub 2 are alike, r sub 3 are alike, and so on through r sub k. The number of permutations can be found by this formula. In the numerator is n factorial all over the denominator r sub 1 factorial times r sub 2 factorial times up to the last factor, which is r sub k factorial. Let us have an example. Find the number of rearrangements of the letters in the word distinct. So using this formula, we will write here 8 factorial because the number 8 comes from the number of letters of the word distinct. Now in the denominator, we have 2 factorial times 2 factorial because both the letters I and letter T are repeated twice. So let us simplify this. The 8 factorial becomes 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All over 2 factorial is 2 times 1 times 2 factorial is another 2 times 1. To simplify further, we can cancel this 2 times 1 with this 2 times 1 here. And this number 2, we can cancel with number 4, and the number 4 becomes 2. And another number 1 is in the denominator that we can simply ignore. Now let us multiply 8 times 7 times 6 times 5 times 2 times 3, and the product is 10,080, and this is the number of arrangements. This is our final answer.